We have a number of remote people. Remote people, a problem we're having, we're having a bit of audio gain problem on this end. So it, you may have to be assertive when you talk, and we'll try to all shut up on this end, so you guys so we can hear you. Okay. So we've got Ron, Chuck, Don, Haven, and Larry, and you were all but Chuck, I think, we're at. Or no, maybe Chuck, were you here in October for the kit building?
No, I wasn't able to make it that day.
Okay.
I do have
that's right. I just remembered I gave you a kit, didn't I?
Yep.
That's a separate thing. Well, anyway, Chuck, Larry here is a member of the board of directors of the Forge, and the rest of these guys are. I'm sorry, except for Dave, and you're also a member of the Forge Initiative. You're not a member of the Forge Initiative? We're sitting in the Forge.
Since before COVID.
TriEmbed.
Right.
Right.
When he used to be at NC State?
Yes. Okay, sorry about that. So he's a TriEmbedder who hasn't been to one of our meetings lately. And Haven has also been past at meetings, as has Ron and Dawn. Well, we have here that maybe they don't. No, I think everybody knows Nick, Rob, Paul, Carl, Dave, and Dan. And Jamie is over here in the corner.
Hello.
Camera's pointed away.
Get me to turn the camera?
Them a little bit. Will we still be in? I mean.
Actually, this just barely brackets
He'll
everybody.
lean forward when he talks, maybe.
Well, maybe he'll lean forward. Yeah. Okay. All right. Okay, so welcome to the Azure project meeting. We haven't had one since the middle of October. We had various situations that took Nick and I out of the picture for a good stretch of time, and then took us a while to kind of get things limping again. This evening, we're going to go through the state of the system, and Nick or I are going to demonstrate what the current system looks like, and
sort of the order that we're working in is I get stuff working, and then I give it to Pete, and Pete sees if other people can get it working. And so they're getting it off of my system and onto more generally accepted systems. So what I will be showing you is what I'm doing, some of how I'm doing it, and where I'm taking things.
okay. I have to rebuild this with the Wi-Fi of the local network that we're on right now. So, Nick, why don't you talk for a while I set this up?
Talk amongst yourselves.
Yeah.
Well, if you move the window where you do that onto the other screen, then we could watch and see what you do.
Yeah.
That would be interesting.
Yeah, you could do that. I mean, I could do that.
Okay, I could talk, it's,
Hold on a second, I'll, oh, I know what I'll do. Here.
The versions on my machine are always unstable. It reflects, like my dog, it reflects me. We've been playing with the Dialog FPGA, which is, I have one issue with writing to some of the non-volatile space that I have not been able to resolve on that. And I have gone to the extreme of actually reading the manual, which is, one should be able to, impugn what's going on from, but no, I'm actually going through the manual and trying to understand.
Do you have a temperature?
Yeah, it's the COVID, that, it's affected my brain. I am, there's a minor issue. I can get it to do everything except for this one thing, which involves power cycling the machine. There are, doing that, it's a really neat chip. When I start to get into, there are all sorts of op amps and things you can do, and it's really, really quirky. But if you can wrap your head around some of the quirks, you've got 5 amplifiers, you can set bandwidths, there's an auto zeroing, it's got some good stuff in there.
What chip?
What?
Which chip are you talking about?
The dialogue chip, the FPGA.
Oh, the one that's created for it?
Yeah,
Yeah, the one that's on your board,
Oh,
Yeah,
okay.
that one.
the little tiny one on the green board.
Really, it's, I'm sort of getting used to it. And it's got some stuff that makes me happy. I've started
Crazy.
to expand out into other things. And I'm doing one of the things that I got going was a ultra precise temperature sensor, which I'm using to make graphene. I need to do a recrystallization process. And I need to have highly calibrated temperature probe. So I have a very, very accurate probe. And I can actually, I plugged that in basically this morning, and by midday had it actually running and graphing data, which makes me, it's entirely a different I2C bus. It's not a complicated one. It just, everything kind of, it says that I've got some parts of the architecture reasonably nicely done. I have spectrometer, which is the next thing that's going on there. 18 channel spectrometer, and a bunch of other. So I'm sort of exploring the general ability to do I2C stuff. And with the temperature sensor, I had it graphing data within 4 hours. And there were a whole bunch of stupid mistakes obviously I made. By the way, COVID makes you stupid. There was a point that I could look at my code and I said, who the hell wrote this? Which is probably my general state, but I can recognize my own code and sort of understand it these days, which is, it had me worried for a while. So I'm the next thing I'm playing with is a spectrometer, because that's some of the stuff that I do when I want a spectrometer working. It is, if I developed this sort of to be able to do what I needed to do, and presuming that other people needed to do similar things. And I had the temperature probe. Once I understood what I was doing, I had it probably working within 20 minutes. And I don't want to do it today, but I'll go through and document exactly how, given a brand new chip, you can get it running really, really neatly. The interface is clunky, and that's the product of having one person sitting in front of the computer for way, way too long. And it needs to be unclunky, but
Right.
the bones are there. The I2C, the dialogue thing is a nice drop and drag. It shows you all the data, it loads the data, not always to the correct place, but it loads the data. And there's and I'll show you, there's what I call a busy box, which allows you to set the values of the two resistor ladders to, and you have sliders. You can actually slide the resistor values and set them. There's a blinky rate slider. These are not, they're not part of the general release because I'm still screwing with them. But you can adjust there are two 1,000 element resistor ladders which you can use to adjust offset or gain in auto zeroing amplifiers or whatever. And they are, so I'm sort of expanding this busy box out so you can actually see it do things. You'll be able to set some of the I2C pins. You will use the dialogue tool to create the majority of what you need to create. That requires a pretty well put together tool. Once that's created, it reads the original dialogue file. There's no translation involved. It simply brings in that file, and then you have the option of loading it out to the device. I'll show you pieces of, Pete is in charge of the release code because I'm in charge of the unstable code. And we each do what we do the best. The code is marginally usable at this point. Let me correct that. Pete has got the code running on his machine, which is.
I did. I did. Past tense.
He did.
Past tense.
He had it. It worked.
Yeah, it worked. Past tense.
It
It ain't working.
it ain't working. Okay. I'll take a look in a moment.
I hate Wi-Fi.
Recompile. It sometimes. Did you do the I2C the config? Change the IP address on the config for the ESP.
No, I changed the SSID and password.
Okay. Yes. Okay. Then that.
It should have worked.
That should work.
Until that.
What does the window say it came up as?
Here. This is what you got.
Okay.
So we don't have an ESP home.
Okay. Well, hit test get menu thing.
They do what?
Hit the get test menu. See.
Yeah.
Okay. Now I'm doing okay here.
Yeah.
Yeah. It worked. You
No, I just had to kick it in the butt. Huh?
Yeah.
So
the
what?
test.
Could you explain that? Why did that happen?
Because I have, in this particular release, I've broken everything down so that instead of auto loading, because I can't tell what the hell happens when auto loads, there's a button that will normally happen when you go to that page automatically. But if I do that, I can't debug what I'm doing.
I haven't had to do that.
Yeah, it is.
It's a manual step mode.
It's a manual step mode. Yeah, there is a persistence feature in this. If you go over to the
So there's like a cookie or something.
It's a cookie that knows that, but if the MDMS address is different, then it doesn't know about it.
Okay, well that'll make an interesting note in the how-to.
Yeah, these little details.
Yes.
This is why we
It's-
have
It's the difference
erasers.
between success and failure.
Yeah, it is. The menus should be live and they should come up, but,
Okay.
Yeah.
And obviously, this is an area that can be optimized at a future date. So, apologize for the camera.
okay, and let me, let me explain to you what it's doing.
Okay.
From a technical viewpoint.
So this is the money. This was the functionality that we were
Okay.
struggling to get.
What it is doing is, the ESP has a local address. It's called an MDMS address, and you get the idea. That is broadcast when the machine comes up, when the ESP comes up. The problem is that the browser is in JavaScript space, and JavaScript has no way of knowing what the MDMS is doing.
Can we turn that around a little? So what MDNS stands for is multicast DNS. And it means you can query, just like ARP works, you can query for a DNS level instead of an IP level address. And so what happens is the computer is totally happy that it knows what IP address holds this DNS name, right? Because it's just like if you had a computer that had a MAC address and you ARP and it said, I've got this IP address, and then you reconfigured the computer to be a different IP address, there's no reason to ARP again, right? It doesn't say, hey, tell me where it is. It's like, I know where it is. It's in my ARP table. The MDNS says, I know where that DNS name lives. It's my DNS table. They go to
Speaker's
the
on,
IP
my
address.
mic's off.
And then you change the IP address, right? You effectively changed what it was, and now you have to take it to tell it that it should do that again.
Well, it is, yeah, and the problem is that you can't do any of that in JavaScript, because JavaScript says this is a violation of terms of service, and we are going to shut your YouTube videos down and send you to re-education.
Right, you will be fixed.
You will be, however, what I do is I scan, I go through the current name is ESP home. And I've set the ESP up, so if there are two of them and they conflict, the next one comes up as ESP home-1. Okay, what happens is the JavaScript then goes through and looks for ESP home, ESP home.1, ESP home. So it will look for multiple devices. So it scans through, each of the devices will have an ESP home menu associated with it. The device, it then gets the MAC address and creates a little database in the cookie file so that you can, even if the MDMS home address has changed,
MAC address wrong.
it still gets the same MAC address. And there is the concept here of what I call a friendly address, which is an address that you can select. So you can have your board called Fred, and that comes up, so you can always find Fred the board, and that is unique to that board. So it is. We had some fun playing with naming, but it is actually reasonably robust. It will support an arbitrary number of, so I think I selected it 10, and it goes back and it does a scan and works out what addresses are active and displays them. So that's what's going on under the hood here. Once the connection to the board is made, you get there's a test get menu, which goes out to the board and says to the board, what menus do you have? And those menus, when that ESP home thing appeared, that was the result of querying the board and returning the menu structure. That menu structure is reasonably dynamic in that the actual menus occur and can be got from the JavaScript code, but whether you can have menus for a whole bunch of devices, but whatever that specific device tells the system. So the Rensselaer, or whatever it is, the dialog site says that this board has a dialog chip on it. It says, I need the menu structure for that. And that menu structure should be got from the website, so it's completely dynamic. It loads all of the menus into lazy linked into the website. It doesn't quite do that yet, but you know, that's so you can have a device. A company can produce a device, and when you flash the ESP, it says, I need this menu, goes out to the company, it can be any IP address, grabs that menu structure and links it in. So everything, you've got 3 dynamic websites, which will make Carl and his security consciousness prickle. I can see he's glaring at me. There are a couple things. Currently, the code is HTTP. It's not HTTPS, but all of the handshaking and password stuff exists in the code. It's just I'm not going to debug that. It would cause me great physical pain. And it requires special permission called cross resource something or other to get to that. So the sending and receiving machine have to exchange. Can I actually do this? Yes, you can. Blah blah, and then they can exchange passwords. So there are provisions in there for much more security, but at the moment,
you won't get any security unless you use HTTP.
We understand that.
Yeah, I understand that. It is. I also won't debug the code because I can't put a sniffer in there because I can't see what the code is.
Yeah.
So yeah, no, it is. All the provisions are in there for HTTPS, but it at the moment it is set for just straight, and that it's a minor change, but I'm for my own sanity.
Yeah, I mean, we also,
You can't change it or fix
Yeah,
it.
I can't.
That's the whole point of it.
Yes.
Yeah, the cores is just cross-origin resource sharing. So that just means that you can specify to start loading things from a server other than where you started.
There are plans to make that more sophisticated, so it's basically ephemeral.
Yeah.
You
They have a very poor speaker on that end. I doubt they can hear you.
And encrypted.
And encrypted in the
ESP.
the ESP system. So, shall I?
That's
continue?
one of the, that's
Okay, so what we got, to recap a very important issue is that when a person is setting up their system to start with, anytime a new SSID, Wi-Fi SSID and password are used, you have to use this test get menu button to get it started. I'm composing instructions, step-by-step instructions, and this will be part of that. But to recap, we started the web browser. I mean, we pointed the web browser at the web server that's running on the local computer, and it's talking via port 8080, and it rendered the initial menus, not including this one, not including ESP Home. And it wasn't until we used the temporary test get menu kick in the pants to get the handshake, and now it renders this ESP Home menu, and presumably, if there was a second device.
The second device, you'd get ESP home
It would be-
one,
Yeah.
or you'd get the friendly name there.
Or -1.
And if you go to the admin button in the corner, and you click admin, do a log out, this is the password, all the password stuff. You click on that again, you click there. And you will see that, if I'm not mistaken, the configuration is gone because you then have to relink the device.
What's a blinker?
Blinker, don't worry about that.
Okay, that's just a temporary thing. I
Yeah,
mean, that's a future thing.
Yeah.
All right. So we go back and we do the test get menu and the OK, and here's our ESP home. So these are the menus that the ESP32 board, in case anybody remotely hasn't seen it, this is the, in fact, I don't know if Ron might be on or not, but this is the version 2 development board, and it uses.
They're all they're looking at is the web screen.
Oh, that's right.
Yep.
Never mind.
No, if we select
Yeah.
the
So
end
anyway,
color, right,
the
you can see that.
ESP32 board. So there are 3 sets of menus here. We're going to start off with the I2C menu, and there are 3 functions. The read and write are not very interesting, but the scan function puts up a matrix for all of the possible accessible addresses. And when we click this scan button, it goes out and it finds on the I2C bus that's connected to the ESP32, it finds 4 addresses. And basically that's the FPGA chip saying I am able to, I'm responding to those 4 I2C addresses, and presumably then commands can be issued to one or more of them
And you can have
to do functions.
You can have multiple dialog boards as long as they are at different I2C addresses. The I2C address is selectable in the code. I have here my temperature sensor thing that comes up at address 72, and so you'll see that address on my system light up. So it tells you everyone. It says, "Are you home? Are you going to time out on me? If you're going to time out on me, I'm not interested." And it displays, what. So these are the active ports.
Right. So these 4 I2C addresses are part of the FPGA hardware, and it's responded to a scan of the bus that was initiated with this button. And this basically gives you a second assurance that everything is working as expected, and the FPGA on the development board is talking.
And it also gives you the data. That cryptic line above it is what ESP pins are connected, what the speed is. It's all sort of internal data because we've had, different boards have different addresses, and it will cause you great physical pain because you don't know what you're connected to. You don't know what. So it's right there.
So what we're saying, currently there's a great deal of debug information that's just below the surface or above the surface in the case of this information that we're looking at. We're talking about this line here. And so the next thing that's of interest is if we go to the Renaissance menu, this is specific to the FPGA. And we can use the read file command to bring up another matrix, and this in turn is going to show the data that is placed in the FPGA to cause it to function. Now, the step-by-step instructions right here are going to say, you just have to know that the next thing to do is to bring up a file chooser. Click, click. Maybe I didn't click it. There it goes. And because I have Raise on Focus, I have to be very careful because otherwise the windows will just vanish because they get covered up by a window in front. So now I'm going to use this to navigate very painfully to, I'm sorry. Man, this is. I think I've gone blind. Where the hell is the, is it? Sorry. This is amazing. There it is. Oh, it's not in alphabetical order. Okay, so now we're going to go into the CAD directory in the repo repository. And we're going to fetch Nick's Blinky app. Some of you may be familiar with these with these files. This is the original FPGA application, and it is tied to the previous generation of synthesis tool, which in turn is the old Quarkus code is dependent on that version of the synthesis tool. Well, time passes, and there's a new synthesis tool that's available, and not surprisingly, they've messed around with internal interfaces that Nick's code is sensitive to, and so we have to use this app file that was created by the new current version of the synthesis. So we grab that and we drop it into this matrix area, and nothing happens, but it did actually do something. Yeah, and so oh, I don't see any numbers.
I don't see. Try dropping the original one. I don't see. Oh yeah.
What happened? Well, one thing, the recording we're doing for Jitsi is beating the heck out of this laptop.
Okay, try dropping test one. See what that does.
Well, it won't work. We're dependent on test two, but
okay.
But that's interesting. Okay. So let's try test one. And the demo comes to a stop again.
Something broke.
Yeah.
What happens?
I tested this immediately before I packed the car.
After you drop it, if you read it again, does it show? Oh, something has happened.
Yep. No, close the second window down. Close that window, go back to the other tab. Okay, go back to
This
it's working. It's just working very slowly.
let's try. Let's just
okay. Well,
let's get a fresh start there.
What it does is it reads the. I had to reverse engineer the dialog files,
Wow.
which
Isn't working.
And I read the raw dialog files, and
Yeah, I think the recording is slaughtering.
yeah, there's something.
It's slaughtering the laptop. Yeah.
It takes a little while for it to happen. Things are happening very slowly. It reads the. It reads the. Normally this happens it takes 2 or 3 seconds. Let's see what it does.
But the idea is it reads the file and then it writes it into memory on the device.
It reads it into file. The first thing it does is it writes it into the matrix. So you can see what the data you're writing is. And once you can see what the data you're writing is, then you have the option, there are 2 buttons there. The first button flashes the RAM on the dialog chip. The second button the second button flashes the double EEPROM so that whatever you have done is permanent. It works. It flashes the double EEPROM. There are some complicated conditions to do with restarting the dialog chip so it reads the EROM. I have not mastered that process yet because while I'm reading the damn manuals, we don't read manuals.
So I confirmed the laptop has a what's called a load factor of 10, which means it's just being beaten up quite a bit, and that's why things are going very, very slowly. And there must be a
There's
timing.
A whole bunch of
Is there a rendezvous?
there's a whole bunch of parsing the dialog file that goes on. I can assure you it does work, but it doesn't like the you are taxing the poor little CPU.
Well,
it does work.
It's Chrome. There were 10 or 12 Chrome processes
Okay.
running simultaneously.
Okay.
And I don't know why, because we've only got 2 tabs.
Well, if one of there are some Chrome, when a Chrome process dies, it produces a zombie file, which lives until you reboot the damn machine.
Yeah, but zombies don't consume time. This thing is
It's
the
zombie file it produces is one that wants to write what went wrong with Chrome out to the great mothership of Google.
That's a different definition of zombie. A Linux zombie process is one that is waiting to deliver its exit status.
Yes, and
it ain't doing anything. It's just sitting there.
Well, in this case, it's waiting for the mothership, which is Chrome mother, to acknowledge that it's sending a gigantic whopping file to Chrome, which tells it that your Chrome crashed. I know this because I have lived,
Okay. Yeah. So, but
when you drag and drop it, it does work. If you are not,
Okay. So I have to use your imagination now. So the contents of the app file populate that matrix with red numbers showing the hexadecimal byte values of all of the bytes. And then if this, where's my mouse? Then if the flash RAM button is pressed, the binary is copied into the flash memory of the FPGA, and the application starts running. And what the application is it takes a clock, an internal clock source, and it runs through a divider network and divides it all the way down to 4 flashes per second. And then the signal, the 4 hertz signal, is then fed into this yellow LED, and so the LED blinks.
It blinks. It's exciting.
Yeah.
Now, if the net result of this is if you don't have Gypsy running in the background, now give it a go down to the busy box thing. See what I left. See what this has for busy box. See if it has anything.
I clicked BusyBox.
I think we are crashed. I think we are dead.
Think so? Yeah, I mean, it did put up an unresponsive.
Okay.
So
there is a the busy box, and the busy box thing has sliders and some buttons that allow you to change the resistor network inside of the dialog chip. They allow you to change the blinky rate. They allow you to modify, and the one version of it allows you to graph temperature. There's a whole bunch of things that the VisiBox does. This is experimental code that I am playing with. So it's not guaranteed to work. But okay. I don't know whether, I was gonna show some of the VisiBox functions.
Well, if you do it on your laptop,
Then we'll have exactly the same problem.
no, we won't, because the load factor 10 is on this
Yeah.
laptop.
Okay, well, let me share my screen. How do I do that? Stop.
You go to the bottom.
Yeah,
There you go.
okay, share.
As I understand it, it's what manages how resistor things.
Okay,
inside
that-
the FPGA.
Am I sharing my screen? Oh,
It's not
this is
usual
exciting.
thing.
Well,
Okay,
part of it-
I'm gonna- These are, this is not working as well as it should. Well, okay, not bad. This allows you to set the rate of the blinky speed. These second two things are set up so you can change the rheostat value, so you can actually change the gain of the various, and there are other things that I'm planning for this that allow you to intimately control all of the things going on inside of the dialog chip. So you can do a whole bunch of things. Now, I'm going to switch to, okay, how do I do this? How do I do it? My screen. Okay, I'm going to, I gotta, well, what I was gonna do, which, I can do if the great audience wants it, I can bring up my board, which is different from everyone else's board because it's mine, has a temperature sensor, the hyper-accurately temperature sensor. And that this morning wasn't working. Now it will actually graph the temperature data and produce a fairly crude graph of what is going on with the temperature.
We'd love to see that.
Yes, we will.
Okay, well, okay, you want to see it? Please, okay.
Please, sir, may we have some more?
Yeah,
So,
okay.
While he's setting that up, Larry just sent a chat. Hi, folks, this is fascinating, and I applaud the work you're doing. I'm also thrilled that this is going on in association with the Forge. That said, I think the stage where the project is too early for my level of understanding. I'll follow from a distance. Send good vibes for continued success. Feeling a bit like I'm trying to understand the conversation at a foreign coffee shop. So he's signing off. And one of the things that we will obviously be putting energy into is getting the documentation sorted out to, the priority up to this point has been to getting a base functionality, a prototype, a viable prototype running, and now we can start making it pretty. We can also start asking questions about the architecture and whether or not different features would be useful, and
What it might be used for, so
well, and the other very important thing is that we've built all of these kits. A bunch of us have got these development boards. We can start turning attention to making applications, and especially as some of the other features come on board, supporting additional devices and so on, we can leverage those things. And I know, Dan, you're particularly interested.
Inside this
He's-
man's got drooling.
He's interested in, Dan's doing some stuff with basically large numbers of 6-axis sensors, accelerometer, gyroscope sorts of devices, and being able to kind of tame the data from those devices is high on his list.
Well, in addition to IMUs, I need to be able to use pots and sliders and buttons and knobs and
Yes.
all of those sorts of things, and I happen to have a whole bucket full of
Oh, he
I2C devices that do just that.
brought some show and tell.
So, I'm ready to plug it, or plug it right good.
Okay, so how are you doing?
What is the status of the boards we built months ago and
The status is that you need a blue wire from, in fact, we can dispense some wire, but you've probably got some 22 gauge solid wire. There's a connection.
there's one more wire that has to be added?
One more wire that has to be added. And it goes from the second pin here to the leftmost pin right there. And we're just wrapping it right around. Yeah, I made a improper interpretation of some docs, and it turns out that the external USB 5 volts has to be sourced. I mean, it has to be supplied, even though there's 5 volts. The USB differential pair data is being handled at 5 volts by the chip, but there's a dependency on the external. So here's the wire. So it goes from here to here. And let's see, who does not have that?
Can we take
So
pictures?
I've got the same problem he does, I only got I'm
Yeah.
missing that one.
Yeah, so let me, Dan will not mind us dispensing here. It's the blue one. Won't mind us dispensing some of this. Who does not have a 22 gauge solid?
At home I do.
Oh, okay, well,
I just need,
so,
okay,
so,
somewhere there.
yeah, so it's,
Documentation to be provided.
and if you go to the current assembly instructions, it's shown in detail.
Oh, it's
Oh, you
it's
have
on
it,
GitHub.
you have
Yeah,
it in
it's
the
on-
PDF now, that's online.
Absolutely.
Okay,
Yeah.
perfect.
Yeah, Dawn
That's
made a pass through the assembly instructions and made them beautiful. And
So then I have a good board, but what do I do with it?
Okay.
There's some about a thumb drive and there's 2 USB ports.
right, so let me ask you this: do you have any capability of running Linux at home?
Yes.
So if you can run Linux at home on your computer, you don't need a thumb drive. So the thumb drive is relevant to people that have no capability of running Linux, and basically they can just boot their laptop off of the thumb drive and run Linux on it to play with it, because we're still working on direct support for Windows. Some of
I
the
assume the thumb drive has more than just Linux on it though. It has like
It has Linux
expressive stuff and
It has Linux and
Absolutely.
all the tools.
It's a
Yeah,
fully
it ha-
prepped
it-
live
so-
CD.
so it has
so
Linux.
my Linux isn't gonna help. Right? I'm gonna have to do installations and whatnot.
So basically you have to put prerequisites onto your Linux system. And the hardest thing, the thing that I'm not even sure how to do with Windows is make the program called PNPM available. That's the program that runs the aardvark JavaScript code and provides the server that we connect the web browser to. And I don't know enough about Windows to know whether or not,
We just need NPM.
yeah,
Okay, so I can help with that. I can run NPM on Windows.
yeah, and we, all of the code that's inherited from Quarkus, and which, of course, Carl's gonna be overhauling the tools related to that, but they cover in full detail the getting everything set up on a Linux environment. So if you have a Linux system, there are just a few steps, and in fact, I can include that in the document that I'm working on. There are about roughly 10 packages that has to be there. And then the expressive tool chain, the expressive IDE.
This is what the original install tool did.
Correct.
So technically, you should be able to run the Quarkus stuff and get everything set up.
Except for PNPM. We've cut over from NPM to PNPM.
I don't use PNPM, I'm sorry. Yeah,
And-
that's-
But I don't think there's anything, I think using PNPM is strictly
You can still use,
it's an optimization.
Yeah.
So NPM
Would still work.
will still work, and if that's if that's a thing on a Windows system, then making a pure Windows port may not be as tough as it sounds now. So, but getting back to your question, we're literally just now at the point where we can turn attention to applications and coming up with additional. There's as Nick covered earlier, there's functionality in this FPGA that's relevant to analog circuitry. This particular FPGA's strength is its programmable amplifiers, its programmable rheostats, which can be combined into a potentiometer, and so on.
it is one interesting, there's a slightly different version of this that will drive stepper motors. So the only thing you need to drive a stepper motor is that tiny little chip, and it'll drive 2 amps, which is pretty impressive, actually.
You have something to say?
I was just gonna say, I just looked up PNPM, and it works on Linux by using using symlinks or hard links. Actually uses hard links to make it more efficient. On Windows, that doesn't work, but there's another feature of Windows file system, and it does use it, and so it does work on Windows.
Cool.
There is a Windows version of PNPM.
Cool. So, and that was really the only mystery
Right.
piece.
Something called junctions that I've never heard of, but it works.
So aardvark is built with npm commands, or in the
Right.
case of PNPM, which is what Rob was alluding to, is that PNPM has optimizations that make it vastly faster,
And it uses less disk space.
using less disk space by using tricks with links rather than file copies.
So I was under the impression that the install script and all that was kind of going away.
It is, but
But there has to be some mechanism to get the tools on your system necessary to execute.
okay, let's see.
And the simplification is, I mean, the current install has to do a lot of stupid rigmarole that's only relevant to the Quarkus code, where it's having to edit files, it's having to massage source files to make up for deficiencies that were present. But,
Temperature goes up. Temperature goes down.
but that, yeah, here we go. But as I was saying,
Temperature goes up.
there are about 10 packages
This
in the,
is
in the
reading.
specified E that is just part of the environment you have to use. Now, once you've built something, you don't need, you can take your application over somewhere and you've already set up your ESP board. So the only thing you need on a target system with an application is NPM or PNPM to run the aardvark code. So for a target runtime environment,
And
you
in
really
the
don't need
future, is that gonna run out on the cloud somewhere? Or
No, it runs
will
on your
It
web
will
browser.
always run on your
Your
machine
computer.
that runs the browser.
But it could, you could arrange for it to run on a server, on a remote server and point your web browser.
It'll run, I have run it remotely on the Apache. And you can, without having to have the code resident on your machine, it's just an it's a website.
So I was wondering.
Not secure, but it's a website.
That's for you.
Yeah.
I was wondering if, Pete, I was wondering if what might be helpful is to recognize that we have two modes that you just described, just like sort of Java has a JRE and a JDK, a
Yes.
development environment, and a runtime environment, and to develop, at least for Linux, a Debian package for each of those that simply, Debian already takes care of a lot of this in the package manager, right? There's a well-known file format that expresses dependencies. There are post-processing files set up to, I need to do little bits of this and that to jiggle things around now that I'm installed. Would it make sense, like, would it be helpful to just build, I don't know, anyone else here might want to do it, I could do it, build a Debian package where if you're running any Debian system, you basically say, I got this package, I want to install it, and if you don't have the dependencies and it doesn't grab them, you say, please repair my dependencies, and boom, you're good to go, and you have one that's the runtime. So if you're just setting up I want to execute, great, and one that's the development, so people don't have to think too hard about it, and it's a known model.
For the runtime environment, I would think that you only really need like a script that says install PNPM.
For the runtime, you don't have to install. For the runtime environment, it can live on the Etcher website and runs quite happily.
Yeah, but we're actually talking about the scenario where you're setting stuff up on that website.
Right. Yeah, and that's it's
On a
all
web
you.
server. It's a web
Yeah,
server.
all you do is all it is an HTML page. It's a big page, got a whole bunch of JavaScript in it, but it will run. There's no setup required.
Okay, so you're describing a completely different arrangement where you capture the JavaScript that would ordinarily be run via NPM or PNPM, and arranging for that to load when a person visits a particular website.
Right, that there is a cloud-based service for this. So there's two different ways. One is this cloud-based service where my page ends up there, and the other is I want to run it here on my laptop, right?
Yeah.
And I was talking about I'm a developer. I want to have a couple machines where I run it on my laptop, and I want to have one where I develop. That's what I was thinking.
Right.
Then most laptops, Mac laptops, etc., if you just click on the HTML top level, will run it.
Okay.
There's no limit to my fingers. It's an as far as most laptops are concerned, it's just an HTML page.
file.
And you just click on that and everything comes up.
Except
There is no,
implicit in that is the existence of something that doesn't actually exist right now, which is the JavaScript residing on a web server someplace. That you can
no, it's all
No,
better
it's all-
than
so
that.
you've changed how it works. You no longer need a local server. You just need a page that you can access somehow.
Yeah, just, you
Yeah, but you're describing something that doesn't exist.
it doesn't exist, I can do it right now.
It's an HTML file that I can't get. It's not on my laptop.
Right.
And it's not in the
It's
cloud.
the next it's the next release of this, got it.
So how large would that file be?
I can tell you, it exists. I'll go and take
Not big enough to worry about, I
Yeah,
imagine.
it's, in this
The
case,
PNPM is hideous when it's building.
But that's,
in this case, it's,
Unless the file was auto-generated by a Microsoft product, it's probably small.
okay, it's, well, it's, where are the zeros? It's a 1.2 megabytes.
Okay,
The JavaScript file, the total spec, the stuff, yeah. Oh, no, that's the map file. It's only, currently the JavaScript file is 1/4 megabyte.
okay, so we're describing three scenarios.
Mhm.
One is the wonderful one where you've got the aardvark application sitting behind an HTML interface, and you can point a browser to it, and it will just load and run it. The second is where you are generating a local node. Is it called Node.js or just Node?
yes, Node.js if you're
Yeah,
on
so
Linux.
you've got an instance of a program called Node.js, and the Node.js is running this same JavaScript.
It's being the handy server for that file.
It's
And it's-
being the server to make that.
And the advantage of doing it that way is that multiple machines can address that program. So that if you are just one machine and you are, just want to talk to the board, then you just run the HTML file by clicking on it. If you want to form a server, which means I want his machine to be able to connect to the board on my board, then I have to have a server running on that. That's when you run the Node.js.
Yep. And then the other scenario is where you are actually building the Node.js application yourself. You're not just grabbing existing files, but you're actually recreating those, and those require the Edger repository and all
All the crap.
ridiculous number of files that go into the
Thousands.
aardvark.
But it is, if you just simply want to connect from here to here, you just click on the HTML file and you run.
Well, except that we don't have any provision. We don't know where that file is. It's not available.
We don't have an easy way to generate it.
It's on his laptop, but through some process in the near future, we can make that available.
But it is, I generate that file, whenever I build stuff, and then I delete it because it takes up too much space and pisses me off.
1/4 of a meg.
Yeah, well, just, it takes the space to build it.
Nick, when you actually generate a production
Yep.
version for all of this, don't put those map files in it.
Yes.
Okay, one, they're huge, but they'll also slow down the app.
Oh, yeah.
They're only for developers,
Yep.
so it takes a compressed JavaScript file and maps it out so you can read it.
And it does a whole bunch of other stuff. Yeah, but the minimum distribution that you can give to somebody is just the HTML distribution directory, and they click on that.
And the JS files.
Yep, which has the JS files built into them, and I build for production. And
Is the current aardvark portion of the repo set up so that when you do a run build,
Yep.
that file is hanging out?
That file is hanging out.
Very good.
And it is, there are two build modes, as you pointed out. There's a build development, which generates a whole bunch of additional crap that you're not interested in. And there's a build production, which says, we're going to, get this down to the minimum skinny. And Webpack does a nice job of doing that. And then it generates, in addition to that, it then zips the files. So that the files are all, they are, it's a very small footprint.
What is Webpack?
Webpack is the tool that is part of Node.js, part of the environment here. It's is one of those 1,000 modules that are loaded, and it builds the website either for production or distribution. And these are all set for development environments, which means it generates breakpoints, and I have all sorts of, all my uglies are in there. I can do all sorts of very nasty things.
The goal of Webpack, as part of the ecosystem,
Yep.
is that it takes your HTML and your JavaScripts and your other resources, and it rearranges them to be the minimal amount of gets for your browser to do to achieve any given page of functionality, so that you do one get of as small a file as possible and have everything you need for that page to work. And obviously has lots of options so that you can keep all the developer stuff working, but if you do the release version, it does, it puts just the right JavaScript in the file, just the right HTML in the file, compresses it all, and images get compressed down, and sometimes they just get written as raw bytes that compress, and so your browser goes blump, blump, and everything moves really fast.
Yep.
Great.
Your browser can only do 6 uploads on a web page at a time.
Okay.
So as soon as one is done, it'll go to the next one, right?
Mhm.
And keep doing that. So yeah, that's,
Do you mean upload or download?
well, it downloads it to your computer.
But the point is, it can only do 6 concurrently, so you really want to pack those files, so it's not trying to get 25 files to get your one page up, right?
Right.
It used to be, you remember when pages used to load and there was this image and then that image, and right, and
Oh, yeah.
now all of that gets packed into one or a few files, and your browser goes zup zup, and you're going, wow, that was fast, but the developer didn't have to optimize that. Webpack, turns out that's a programmable optimization, and somebody
Nice.
said, let's do that. It's a mess to do. Once you
Oh,
get
yeah,
set up,
no,
it's great.
I'm awestruck by the people that did that. Because
When you do what's called the SPA site, it's a single page application. You pull in one HTML and then you use an AJAX backend to pull in all the data as needed.
And
So you can actually move entire screens around on the fly without uploading any.
And this has Ajax in there. I mean,
HTML.
this is, yes. A lot of this is done with Ajax.
Which
So
is not the cleaning stuff. It's a different thing.
it's so there's it is so yeah it is there are 3 different and these are all built for development at the moment. That's the way they're built. But that's the idea is that if you have a complete virgin board, then you have to have some tools from ESP to load the code onto a complete version board. Beyond that, if it's semi in there, if the board doesn't connect to it holds 3 SSID and passwords in encrypted form. It cycles through and tries to connect to all of those. If it cannot connect to all of those, then it goes into console mode. And the console mode has, the moment it's a little cryptic, but you put in SSID and password. And when you put those in console mode, you then restart the board, it then will connect to whatever SSID you gave it at that point.
Console board over USB.
Does it
Yes.
save it at the same time so that you don't have to do it again?
Yep.
Okay.
It is saved in, there is a special area, encrypted area of non-volatile RAM that all of that stuff is saved in. So it remembers the last 3 websites you connected to.
When I forgot to edit SDK config, I didn't see anything out of the monitor output.
Yeah, no,
So that code is temporarily disabled in our code.
right, it is, because I was having problems with it.
Right.
So it's like, you have to do it the old-fashioned way. My priority was getting the drop and drag and getting, being able to run Blinky, which under the right circumstances you can do. Now I've got a list of things, which is increasingly growing, unfortunately. However, I have a list of things that need fixing. The console code is in there. I just disabled it because it was giving us problems, and those weren't, that wasn't a problem that needed to be addressed. There is another method that I am looking at, which allows you, the board will have two addresses, one of which is the SSID address, and one of which is by default, a set address, which will be, I think, 10004. You can connect to that default address and change the SSID that it will search for. So that you will have, that may be an option. The moment, the moment you change the config file, because that's what you do. There's only so much to do, and there's a lot of damn code here.
But the key element to that is to have that to-do list and focus on getting those things resolved at some rate that is competing effectively with the let's create new features.
Yeah, it is.
Water wants to come out of the bucket faster than it goes in.
Yeah, it is, and I have the beginnings of a defect list that I got to Pete, and hopefully some other people can get this running, and hopefully they will, perhaps they will manage to give me their comments and defects. And it is to the point that I get their comments and defects, and I can point to where in the code it needs to be fixed, and get it to somebody else to fix, because the basic core functionality is there. Okay, until the basic core functionality was there, I'm not going to give it to anyone else because it's a mess.
Yeah, that's a whole other layer to this, and in coming days and weeks, we will be setting up, we have an Edger repo now, and it does not have any ant or aardvark directory in it. And it's going to be seeded with the code once we declare it's solid enough to go ahead and promote it. But the other things are user documentation. We need to address the prerequisite steps. And the other thing that we really need to start doing is running the Renaissance FPGA synthesis tool. And we can have Edger sessions, not Edger, sorry, we can have Jitsi sessions that are just devoted to seeing the synthesis tool run. We've got some additional hardware, special debugging hardware that can work with the synthesis tool, where you can run a simulation and see how it's actually going to behave. In fact, Nick and I use that to debug Blinky app to get it working. So there's quite a bit that we can do in the near future.
But it is, in my diluted opinion, all of the functions are. I was going to say one more thing on the screen, which is that the board we're using has a tricolor LED, and you can, well, it won't work right now because it won't work, but you can set the color of the LED on the ESP board with this page. So you can set
RGB?
Yeah, you can set the color. It's right here on the board. There's a RGB LED, and you can actually. I want to get the temperature running first, but you can actually set the color of the LED, which gives you.
When you hear Nick say "you can," translate that to "you will be able to."
You will be able to. I can. The
one can.
Yes, one can. Nick can.
And there's the one.
Yes.
Not this one, that one.
Yes. So it's as I say, my focus has been getting so that another human being, the one here, can run the code, because I know I can run the code, but that's.
Well, we did, excuse me. We did discover a number of wrinkles just trying to get it running on a different laptop with various little niggles. And in computing, there are only just a few interesting numbers, 0, 1, and infinity. So the fact that we've added one additional operating environment, that's major progress.
And now it's a matter of getting more than Pete running. Anyone else that's brave enough to delve into this and.
So Dan, Jamie, and Larry kicked in the $10 for the bootable thumb drive. And I was really working hard on that this afternoon and ran into an issue that got me snarled up. But my goal is to have 3 thumb drives, one for each of you, and get them to you this weekend. And it will have just exactly the software we've got tonight. And I think if you're running on a
And it'll
computer,
have my phone
The
number.
software with his stuff or the older or the newer?
No, I'm sorry. I didn't mean to point towards that laptop.
Okay.
This laptop.
Right. Okay.
I have 2 phones, one of which I carry with me, one of which stays home. It will have the stay-at-home phone, which gets turned off.
So effectively, the thumb drive is the Quarkus version, is that about right?
No.
Oh,
The thumb
it's more-
drive is going to be is the
Gonna be
latest,
this,
greatest,
Okay.
but it's
your version of the
it's the
latest,
stable. It's
If
the
I found $10, could there be 4 thumb drives?
yes,
Yeah,
absolutely.
it will be the Pete version
Okay.
of the code, which it will not be the Nick version of the code because it won't be.
Well,
I vote that be the first version that goes into this repository.
Yeah, and I mean
Yeah.
that's
Since it's being released to
Yeah.
a number of people and
Yeah.
talking
Yeah,
about.
and that's,
oh, thank you.
Wow, the money just keeps flowing on in.
Yeah, there you go.
Yeah, you better give the 10 back. He sent you.
give him the 10 back.
I'll give it to him.
I don't know what I'm doing.
So
Well,
that's
somebody
2
just
more,
standing
one for
behind
me
me.
and one for
Okay,
Paul.
so
Yeah.
we're up to 5 then. So we're
Thank you.
Okay.
well, actually, the 5th being the master.
Yep.
Will always.
And
Then
this,
there should be a backup for that.
So 6,
Oh,
I
God,
think.
yes.
A master plus 5, because we just added 2 to your 3.
Yeah, but we had 4. So
Oh, okay.
I didn't. I kept it a secret that there was a 4th.
That was the master, okay.
Already.
Yep.
Can you email me the URL you need to download, was it PN, the new?
yeah, I can do that.
Yeah, that way, because I could possibly put that in my original Quarkus
Yep,
stuff,
okay, I'll get
and
it.
it'll download that instead of the NPM.
I will do that.
It turns out that you can install PNPM using NPM. You do a P.
But then you got twice as much crap on your disk.
Yeah, I will download the
The
link.
NPM itself is not very big, but the great leaping globs of libraries that it's
Are-
That's
pulling
where the
in.
big is.
Yeah, there are literally thousands of files that it loads, and it used to download them to the directory, and that would take forever. Now it just puts soft links so that it only downloads them once.
Yeah, but you're right. I mean, a direct install would be much
Yeah.
better.
Yeah, but I will get you the PNP, I'll get you.
Okay, what else?
There's all of where, okay, this is what I'm doing. What am I doing wrong? Where, this is where I'm going, and, I probably over the weekend want to get my spectrometer running on this. Why? Because it's my spectrometer. I want to get running on this.
Right.
And so the code is sort of internally driven. That has to change. I need input from other people that tells me how stupid I am, and then I will turn around and say, well, fix it.
How many I2C buses can we have?
2.
No, you can have more than 2. That's
On
soft.
ESP32?
Yeah, that's soft. You can select 2 pins, and then you can change and have another 2 pins for another bus.
That's 2. That's what I said.
No.
And then you can do it again.
You can do it again.
So
So
are
you
you,
can
are you?
have 5 simultaneous I2C buses?
You can.
Oh, that's
That's the way
switching
that,
So there are
that's,
only,
the other to the
there
other.
are 2 that are defined
Yeah,
by
the
default.
ports are configurable.
Right, so you can expand beyond that.
yeah, you can
There
expand.
still is some limited number of
Yeah,
pins,
a lot
but
of
you have
the
to
more
figure it out.
modern
So
I don't know the numbers.
processors are dual,
Okay.
they're
One other-
all expandable.
something very relevant to you, Dan, is that we're using a very, very low-powered, simple, inexpensive flavor of ESP32. But there's absolutely, the code is already in place to support other versions. We're using the version called C3 that only has just a couple of dozen of I/O pins, if that many. But there are other versions like S3.
Yeah, I have
S2,
S3s, I have.
have many, many, many more I/O pins.
Okay,
And so,
so approaching more of
And I,
TT style.
exactly.
More powerful,
So
more
being able
faster.
to have, yeah.
More power, more processor, more pins, right?
more
Yeah.
memory.
and, if you want to get really tricky, you only need 1 clock, so that you can have, if you have 18 pins, you have 1 clock pin and 17 software-defined I2C buses, and if you're not talking to that device, there's no data coming down that. So you could run 17 devices quite
By
easily,
switching.
and you could actually run more than that, if you get tricky.
Sure.
Or getting nuts.
Very tricky. Okay,
Yeah.
we're talking about
We're talking,
extremely tricky.
we're talking nasty, you know.
But I mean, currently Dan's having to use, or you had been using multiplexer, I2C multiplexer devices, which are a
Pain in the ass.
pain in
Three
the butt
separate
to-
buses,
have to use.
3 multiplexers, and
Right.
multiple sensors on each one.
Oh, and then your other
Multiple types of
possibility,
sensors.
so the other possibility with this, and I don't know your problem, so I may be talking through my nose here, but is they're all connected by a network, right? They're all potentially on Wi-Fi. So however many I2Cs one ESP32 can handle, N ESP32s can handle that many, N times that number, right? And if you're just trying to coordinate, depending on what your timing is like, it may not be much of an issue, or it may be.
It depends, I've looked somewhat at that, but part of the challenge is this is a wearable
Oh, okay,
network
so
with
it might
multiple
matter.
sensors.
And
just trying
let me
across
guess.
the body, so you have to either wire them together, or you have to power each one individually using batteries.
Yeah, yeah.
All
And let me get real sneaky on you. The dialogue chip has I2C outputs.
So use it.
Which, is a whole concept which will cause your mind to explode. But it
Well,
has,
or looked at differently, it's functionally a multiplexer.
you can multiplex, you can do a whole bunch of really neat stuff that I'm just trying to understand the dialogue chip, and there's like 1,000 pages of.
Configuration matrix on the TT.
Yeah, there's just a whole bunch of, and that's what I'm actually trying to read the manual on.
Okay. It's dynamically set all that.
Yeah, it's I don't like it.
But I'd be
Yeah, I
surprised
think
if the, I'd be surprised if the FPGA has the I2C protocol inside of it.
Well, that was gonna be another question.
I think it's more like a dumb multiplexer, like the,
It's,
like the
Are there
ones, the TIs.
block, I assume there are block libraries for certain functions that can be done
Yes.
into the FPGA?
Exactly.
I2C may be one of those.
yep, I'm saying, this is the manual that I'm reading. I am not I'm just getting up to speed
Yeah.
on all of the, and there are 48 different versions of the damn dialogue chip, some of which drive stepper motors, some of which have, they have all sorts of things. they are very, very similar in structure, but there's, I figure if I can master this 74, which is the one that we arbitrarily picked to start with, and
Can
then,
you point me to some of the documentation?
yeah, I can,
Look
yeah.
at it and go blind?
Yeah, it's, if you go to the, if you Google Renaissance, it's the green pack.
Okay.
Well, they've renamed it, and the new name is Forge FPGA.
You wonder if they heard about us, because they're in Chapel Hill and they chose to collide with our name.
Yeah.
And they heard about you guys, right? You were
Oh, yeah.
talking about the Forge.
So on the purple 06 board, we were using this flavor of the ESP32C3 chip.
Right.
Right?
Okay.
And I'm working on a different project, which has a little board that I made, the purple one, the oval, with a slot for the ESP chip. But you need to program them before you solder them in.
Okay.
And they have some pads on the back, 6 pads for programming. So this is my little fixture for programming it before I solder it into the circuit.
Pogo pins and.
Wow.
Yep.
That's great.
This guy's very ingenuitive.
Oh, he is, I've known
Yeah.
him for a long time.
Eons.
Eons, way back.
So Oshpark did not make slots for me
So how did you make them?
on my milling machine. We bought the land mills for the
mini
CNC
mills?
machine. And the very smallest one is exactly the right size.
Perfect. Yeah.
Wow.
And so that's the.
Or if you've got a steady hand, you can use a Dremel.
Do that.
Yeah.
Yeah, that would be difficult, but
If
that's
you
why
can
I
use
said
a
if you had a steady
Dremel
hand.
if you're younger than I am.
Yeah.
There's an age limit on the
With
Dremel.
exactly the right amount of coffee.
Yes.
I actually bought a smaller bit. It's a 0.2 carbide bit, 0.2 millimeter. So that's 8,000, just under 8,000ths of an inch.
I didn't look at
No. What you've got is more appropriate.
how big this one was. Do you remember? In the Amazon set of end mills?
Yeah, I know. I think it was like 0.8. The 0.2 turns out to only be practical
There's-
for a very
there's
few
little
very weird
holes.
things.
The hands on the slot.
Circuit boards
That's
being
where
one
the
of
slot's
them.
Yes.
goes between those holes. And
I used it to engrave
Oshpark
a
says,
coin
if you
where
do
I
it
needed,
this way, it's
I
probably
had
gonna work.
prismatic cuts for the letters,
It didn't.
and I needed to do clearing inside the letters.
Keyword probably.
It's,
We make no promises.
That's right.
and that's
That's what they say.
we'll talk
They say
EDM.
if you want to do it right,
Well,
you have to do all this other stuff.
can you do EDM without going through?
Yes,
Okay,
But it's
you're just eroding the metal.
sure.
kind of
It's like etching.
oval.
Right, it's not wire EDM, it's EDM. Sure.
Yeah, just, you take a syringe,
Right.
or you take any size.
All of them.
Okay, you do.
Every EDM I've looked at has been a wire EDM,
Yep.
so I haven't seen all the
No,
possibilities.
you can take, a piece of carbon and
So
carbon
I'm making
and
a
just
pickleball
erode the surface.
scoring
Yeah, the wire EDM is fun,
which I
but
have on my car.
the point EDM lets you put
This one.
ridiculously small holes.
Right, it'll make my 0.2 seem big.
Big. There was a famous case at a show in Russia where the Russians claimed to have made this tiny probe, and the Americans were demonstrating an EDM machine, and they at one point drilled a hole through the probe with their
Round
EDM
or you didn't-
and returned it. It's a very famous, gotcha.
That's the right thing at the score.
Score table lights up.
It's the good thing.
Well, I think that the meeting is,
Has degenerated
Right,
into.
the recording is gonna be less meaningful to people starting from about here on.
Yeah.
about
And I
20
actually need
minutes
to
ago.
go do a couple things downstairs,
Yeah.
so. That doesn't mean you guys have to be kicked out, I just need to come and close up afterwards.
Yeah, we need to, okay,
The chairs and tables
So
are all in here.
Kill the
so-
recording, say goodbye, kill the recording.
They gotta
Save your
cut
chat.
paste. Yeah.
Okay.
Save your chat.
remote people, we're we're winding down now. We can leave things set up, but we're stopping the recording. I'm going to try to stop the recording.
I got myself a Christmas present, which is one of those little spectrum analyzers, 6 gigahertz spectrum analyzer.